Hi class, Mrs. Matheson here. We're going to be covering notes 5 for unit 9, and our learning target is I can divide rational expressions. And the nice thing about this is it's going to be very similar to multiplying rational expressions. We are going to, just like when we divide fractions, we multiply by the reciprocal. We're going to do that for rational expressions. We're going to multiply by the reciprocal. Remember, the reciprocal is just flipping the fraction. So some of you may have heard this as stay, switch, flip before. Same idea here. Stay, switch, flip. Okay, so our first one here that we're going to look at, number 1, we're going to keep our first fraction as is, 5x squared over 7. We're going to change to multiplication, and we're going to now have our reciprocal, or flipping the fraction. So let's go ahead. You guys like to multiply them across and then simplify, or you can simplify and then multiply across. So let's go ahead and just do this first one by multiplying across. So we're going to take 5 times 21, which is going to give us 105, and then we still have our x squared. We have 7 times 10, so that gives us 70, and we have x cubed. 5 is going to go into both 105 and into 70. Can we go bigger than that? I think we can. Let's try 35. Yeah, 35 goes into 105 3 times and into 70 twice. Now look at it. Which one has more x's, the top or the bottom? And the bottom does good by 1. And then don't forget our direction says to state the excluded values. So we're thinking 2x equals 0. Divide by 2, so x equals 0, and then we say cannot. So don't forget, both parts of these are the solution. Okay, let's go ahead and look at problem 2. Not too bad for problem 1. Let's try problem 2. Keep the first fraction as is. We have no simplifying to do, so we don't have anything to factor. We're going to change it to multiplication, and we're flipping that second fraction, n plus 4, and then 2n plus 2. Do we have anything we can simplify? Yeah, good, right here. So let's keep the first one as is. Keep the top, n plus 4. And here we're going to take out a 2. We're left with n plus 1. So we're canceling out only if it's in the top and the bottom. So we are left with, let's go up here, n plus 4 over 2 times n plus 3. We have excluded values to do, and we have to also remember to simplify the bottom by timesing that 2 back in. So let's see here, n plus 4, we're going to times the 2 back in, so we get 2n plus 6. We can set this bottom here equal to 0, or we can go back up here and set it equal to 0. Either way, so 2n plus 6 equals 0, minus your 6, and then divide by 2, so we say n cannot equal negative 3. Let's look at it at this part here. 2 times n plus 3 equals 0. Divide by 2. So we get n plus 3 equals 0, minus your 3. So we say n cannot equal negative 3. So see, either way that we can do that, we get this excluded values. So here and here are our solution. Okay, let's travel over to problem 3. Problem 3, we have our 15y squared over 4x, change to multiply, and then switch or flip your fraction here. Now this time I'm actually going to simplify before I multiply because I know some of you guys like to do that. I see a 4 and an 8, so I'm going to get this to a 1 and a 2. My 5 and my 15, I'm going to change to 3 and 1. All right. So let's see here. On the top, I have a y squared, and on the bottom, I have a y. So it simplifies to just a y to the first on top. On the bottom, I have an x, and x to the third, so that's going to go 2. All right. We have a 3 and a 2, so that gives me 6. We have an x squared, and we have a y. And nothing left in the bottom, so we can have it over 1. Don't need to, but we can if we want. All right. Don't forget, state excluded values. There's no variable in the denominator, so there are no excluded values. X and y can be anything, and it's not going to affect the denominator. All right, let's go ahead and look at 4. 27c cubed d squared over 11d. Change to multiply. 9d to the third e. And then 2c to the third. Okay. I don't see any numbers that I can simplify. So let's just multiply across the top. We get 243. And on the bottom we get 22. Can I reduce that fraction? There's nothing that goes into 243 that also goes into 22. So actually my numbers stay as is. All right, I have a c to the third in the top and in the bottom, so those are going to cancel. I have a d squared and a d to the third. So secretly I'm thinking in my head, that's a d to the fifth. And I have a d in the bottom, so I'm going to change that to d to the fourth on top. And we have an e. That has nothing to go with it. Again, all I have left in my denominator is a number, so there are no excluded values. Okay, so let's take a look at problem 5. Actually, you know what? I'm going to leave you guys up to problem 5 and 6 on your own. You'll see those on your quiz. So just a couple of reminders. Keep the first fraction, change it to multiplication, flip the second fraction, then factor. Don't forget to factor. All right, so taking a look at our back page of our notes here. So I'm going to actually do a couple steps at the same time. I'm going to factor the top of that problem 7 as I rewrite it. So I'm thinking what multiplies to my 2 and adds to my 3? That's going to be 2 and 1, and I can use my shortcut. X plus 2, x plus 1, and then I keep the 4 on the bottom. Okay, multiply. And this is nice. I'm just going to flip my second fraction here. Okay, so now I'm looking for anything that I can cancel out of the top that's also in the bottom. My x plus 1s are both in the top, so I can't cancel those out. So I'm actually going to have them both in my answer. X plus 1 times x plus 1, and all I have in the bottom is 4. The thing is that we need to simplify that top back together. So we have to either do foiling or we have to do box method. So I like to FOIL. That's what I grew up with. So I have x squared. I know I'm going to get an 1x and a 1x. So I'm going to have plus 2x. And then 1 times 1, that gives me a 2. And my 4. Now here's the thing you need to keep in mind, that I cannot simplify the 2's and the 4. The 2's in the top and the 4 in the bottom, because the 2's on the top are part of a trinomial. So it's pluses in there that makes that a trinomial that I can't factor or can't simplify that anymore. And then we just want to say no excluded values. Excluded, you got no excluded values, because it's just that 4 in the bottom. Okay, I'm going to give problem 8 for you guys to try on your own. And yes, it will probably show up on your quiz. Let's do 9 together. Again, I'm going to factor as I rewrite my problem. I can take a 2 out of the top here, and I'm left with x plus 2. Okay, what multiplies to 18 and adds to 11? Multiplies to 18, adds to 11. X plus 9, x plus 2. Change to multiplication, and I'm going to flip. That x plus 1 goes in the bottom. Multiplies to 6 and adds to 5. Multiplies to 6, adds to 5, 2, and 3. Okay, let's cancel out what we can. My x plus 2's. I can cancel out nothing else. Well, shoot. That didn't work out very nicely for us. But hey, it's okay. We're left with x plus 2 on the top, an x plus 3 on the top. In the bottom, we're left with an x plus 9 and an x plus 1. Here's one of the times that I'm like, hey, it's a really good time to find your excluded values is now, because the bottom is so nice and it's 2 binomials. So let's do x plus 9 equals 0. So we say x cannot equal negative 9. X plus 1 equals 0. So x cannot equal negative 1. Okay, 2 excluded values, got those. Now we actually need to go back and in FOIL or box method everything back together. you'll see this in Algebra 2 that this is a big thing is to put it back together. And the top, you can go ahead and FOIL first and then times it by the 2, or you could distribute your 2 in on either one. So we get 2x squared plus 10x plus 12. So all three of these things here are our solution. I want you guys to go ahead and try out problem 10. Ooh, lots of great factoring, but I have a good feeling about this one that things are going to cancel. Okay, number 11. In April 2001, NASA launched the Mars Odyssey spacecraft, and it took 200 days for the spacecraft to travel 466 million miles from Earth to Mars. What was the average speed of the spacecraft in miles per hour? Round to the nearest mile per hour. Okay, so we traveled 466 million miles in 200 days. And we want this left in miles per hour. So miles I'm going to leave, but I actually want to make days into hours. So 1 day is 24 hours. Remember seeing this before? We can cross off our day label, and our answer is going to be in miles per hour. Great. So take your 466 million and then divide it by, now make sure you do this in parentheses, 200 times 24. Go ahead. Ooh, it says round to the nearest mile per hour. So round to the nearest mile when you do this one. Did you do it yet? I'll give you a few more seconds. All right, 97,083 miles per hour. Okay, we're going to apply that here to problem 12. It says on July 7th of 2003, the rover Opportunity was launched. It landed on Mars. Assuming that the Opportunity traveled the same distance as the Mars Odyssey spacecraft, because remember that one went from Earth to Mars, how fast did Opportunity travel? Round to the nearest mile per hour. Okay, so that distance that we saw in our last one was 466 million miles. Oh, they just give us dates here. They don't give us how many days. Oh, we need to make that into days. Okay, here we go. July, let's think about this. July has 31 days. Then we have August, which is also 31. September, which is 30. October is 31. November is 31. December is 31. And then January is also 31. But in July and January, they didn't travel all of those days. In July, they didn't leave till the 7th. So count that up. They actually only traveled 24 of those days. And in January, they landed on the 25th, so they actually only traveled 25 days. Okay, so I want you to add up all my days that Mars, oops, not the 30, this one. Add those all up, and I want you to put that in here. And then you're going to follow the same idea. 1 day is 24 hours. Find what this value is here, and then go ahead and do this just like problem 11, and then make sure to put your answer in on our Schoology quiz. We'll see you guys later.